Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians. Welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We believe we can mentor students to think and reason like mathematicians. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keeps students from being the mathematicians they can be.
Hey, Pam.
Hey, Kim.
It's challenge week. I'm so excited.
We love challenge week. Woo!
Oh my God. It's one of the most fun weeks of the year. We do it a couple of times a year. But we love seeing your faces. And I get to talk to so many people in the Facebook group. So I'm super excited about the back half of this week. Not that I love podcasts, but
No, it is so one of the best things that we do all year. It's totally free. Yep. We love it. Obviously, if you're listening to this podcast at some other time of the year, just know, get on our mailing list and join in those free challenges because they are a blast. All right.
Super fun. All right. Down to business. If you haven't been tuning in lately, then you've been missing some great chatter about subtraction and how important it is that we give kids solid experiences with subtraction because it affects so many of the other operations and strategies that we love. So today we're going to continue from last week chatting about subtraction facts.
Yeah, so if you didn't listen to last week, really do, because we talked all about memorizing subtraction facts. What are our favorite ways of helping students really own subtraction facts, really getting them into long-term memory with a schema so that they stick better and that it's all more and more figure-outable. So Kim, what's one of our favorites?
Well, I'm going to mention the first one that I love is Have You Need. And we talk about it all the time because it's super powerful, like the silliest little routine, but super helpful at a young age. We're going to just mention it here because we've talked about it before. We'll link that episode in the show notes.
Well, and to be clear, you only call it silly because you made it up. So you're just trying to all be, humble.
Well, I mean, honestly, there's nothing super magical about it. It's fun mathematically. But the routine itself is basic.
I mean, you need.
There's not a million things to make. I mean, I'm in for not a lot of prep, and
it's good.
It's okay to do it in lots of ways, over lots of experiences, partners, not partners, whole class, different numbers, change things up. Yeah, I'm in for that.
All right, so if you have not listened to an episode on I Have You Need, we'll put the episode number in the show notes, but check that out if that's new to you. If it's the first time you're listening to the podcast, I Have You Need, wonderful classroom routine, all grade levels. It's great.
Yep. So at a young age, I Have You Need with 10, we're talking subtraction facts. So I Have You Need with 10 would be super helpful. But then also once your kids are working and have made sense of the 10 a lot, it would be really helpful for them to work on I Have You Need with 20. And the idea that within the 20, there are 2 10s and one of the teens is being messed with I Have You Need, but the other 10 is just kind of being left alone. So,
hey, I almost want to back you up just a little. Let's just do a quick example with a total 10. So if I say the total's 10, I have 7, you need
3.
3 to make 10, right?
Mm-hmm.
So that feels like addition. 7 plus 3 is 10. Then we want to help kids make the connection that therefore, if we own that 7 and 3 are partners of 10, then I now know the answer to 10 minus 7, but I also know 3. And I also know the answer to 10 minus 3 is 7. And that takes some time and some development, but that they own that. And so then you're saying once we own that, there is that 10 in the 20.
Inside
so
the 20. Mm-hmm.
Yeah. So if I play, I have you need total 20. Kim, if I have 17, what do you need?
3.
3.
And so that 10 in your 17, the first 10 is just kind of sitting by itself, but you have that same 7 and 3 partnership that you had in the 10.
Yeah. So if I say I have 12, what do you need?
8.
And you're thinking about, there's that 10 hanging around, but there's the 2. It's almost like I said, I have 2. What do you need to make 10? It's the 2 and the 8 you're kind of using. And we, you have to help kids kind of experience that 10, kind of sort of ignore that extra 10 in the 20 and kind of focus on those partners. And then you could do the same thing with 30 and not necessarily that you would play I have you need, but that you would make the connection. So if you're doing 30 minus 8, or 30, then can you use the 8 and the 2 in that 10 that's between the 20 and 30, et cetera, et cetera. Yeah. Cool.
What's another one?
Do we want to mention, we want to mention, my brain's all over the place. Similarly, if we've done partners of 100 with I have you need, and if I say I have 63 and you say,
but we're talking about subtraction facts today, Pamela. So I didn't.
Oh, don't go higher. That's why. Because I was just going higher numbers.
What can we do for subtraction facts? So
never mind. Stay in subtraction facts. Stay in subtraction
facts. To the
episode. Not any subtraction. We're talking about subtraction facts. Okay, cool.
So
Thank you. So another thing that we can do, there goes my vertical brain. Another thing that we can do is think about groups of problems and what they have in common, right? Like what relationships are there among groups of subtraction fact problems, how they're related, how they're connected. So you have a favorite one. Give us that one.
So like on a subtraction chart, right? If we're looking at a subtraction, all the subtraction facts, then, I might put up that chart for 5 minutes a day for a week or 15 minutes at a time and have kids talk about like, what do you notice and what patterns do you see? One of the ones that I think is super fun.
Before you go into the one, maybe I'll just describe that just a little bit more. So we might look at a chart where I've got the numbers 0 to 20 across the top and then 0 to 20 going down the side. And then we're kind of looking at where those coincide. And if we're just dealing with positive numbers, then I would look at where, 20 minus 5 would be in the cell where the 20 column and the 5 coincide. And we're thinking that in that cell, we're talking about 20 minus 5. And if we go down to the cell below it, that would be 20 minus 6. And the cell below that would be 20 minus 7, et cetera. So that's the chart. So we might pull that chart out and then we might look for commonalities and groups of related facts.
Yeah. So one really cool noticing is that every time you're subtracting 9, you can be thinking about the teen numbers and you can be thinking about it's always going to be 1 more to get to 10 plus all that extra that was in the teen number. So if it was like 17 minus 9, then you could think about the 1 that you need to get to 10 plus all the extra 7.
So you're really using the difference interpretation of subtraction here. You're thinking about if it's 17 minus 9, you're like from 9 to 17. You think about that 1 and then that extra, the kind of the teenness of it, right? The 10 to the teen.
Yeah, so it's true for every 9, right? Every subtract 9.
Do 13 minus 9.
So 13 minus 9 would be the 1 from 9, the 1 to get to 10, plus all that extra 3.
So it's always, because it's always 9 to 10. So it's always that 1, and then it's just the extra to get to the.
And it's a really nice transition for kids who are counting by ones to be thinking about, oh, I know about teen numbers. It's just all that extra, all those 3, instead of counting 1, 2, 3 from
10 to
11, 12, 13. Yeah.
Mm-hmm.
So getting them used to the idea that what that teen number is made of, so you can think about that whole extra chunk beyond the 10 all in one group.
And so this is just screaming at me. This is one more example of what we're not really suggesting is that you go teach this strategy to kids, right?
Right.
It's not, we're suggesting is we notice it because we're in that noticing, we're helping kids go, oh, that really is true. That from 10 to the 13, it's 3, and from 10 to the 16, it's 6, and from 10 to the 17, it's 7, and from it always is that sort of extra from the 10 to the teen, and then it would just be that extra 1 because we're subtracting 9 every time. We're always looking at the difference between 9. Those generalizations, building numeracy, building the mathematical relationships that we want kids to own.
Yeah.
Because our goal is more than just those subtraction facts, right? Yeah, it's really cool. So another group of numbers that we might look at on a subtraction chart would be numbers that are close to each other. So if I'm going to subtract something like 9 minus 8 or 7 minus 6 or 3 minus 2, that we could think about those again with a difference perspective. How far apart are they if we're looking at subtractions, that difference? Well, if the numbers are always just 1 apart, then they're always just 1 apart. Like, 9 minus 8 is going to be 1, like 4 minus 3 is going to be 1 because they're just, all those numbers are 1 apart. What if they were 2 apart? So if I'm looking at a subtraction fact and the numbers are 2 apart, bam, then the answer to that subtraction problem is 2. That'd be another sort of group of numbers that are related that we kind of look at.
Yeah. So I think once we've spent some time working with these strategies, I love the idea of putting up this chart and saying, like, talk to me. What do you notice? I'm actually glancing at a subtraction chart right now, and there's one that I'm loving that pops out, that going diagonally down on the triangular chart that I'm looking at. There's very clearly a 5 minus 3 is 2, 6 minus 4 is 2, 7 minus 5 is 2. Like, it's screaming a little bit of constant difference to me. And how cool would that be early to just wonder, like, oh my gosh, why are those always 2? And the kids, I think kids could say, well, you're subtracting 1 more from 1 bigger of a number. I was poorly said, but
that's interesting. Yeah.
Anyway, really cool patterns that come out.
And those of you that are trying to teach constant difference later on could pull up those like, hey, look at all this diagonal. Is all the answers are 5. So are you saying that 12 minus 7 is equivalent to 13 minus 8 is equivalent to 14 minus 9 is equivalent to 15 minus 10? Yeah. And so, we're kind of nudging this idea that we can think of equivalent subtraction problems. It's nice. Yeah. Super cool.
But of course, our very favorite thing to do, to work with basic facts or any mathematics, are problem strings, right? We absolutely love problem strings. They build relationships. And so we thought we would do a little bit with some problem strings today. I'm going to give you numbers this time, Pam.
Okay, bring it on.
I'm always in the hot seat.
All right, I got a pen in my hand.
Get a piece of paper. Oh.
And this one's kind of a gnarly pen. It actually leaks a little bit. It's not my favorite.
Which is exactly why you shouldn't use pens.
But it's nice and bold. Anyway. All right, carry on.
Harder. Okay, here we go. First problem.
Right harder. I like it. Okay, first problem.
All right, 13 minus 3.
Okay, so if I was going to do this problem string with kids, because let's be clear, I don't really have to think about these problems very much. Okay, so then I would expect students, if I'm doing this problem string, that I would probably have a range of development in the classroom. And I might have some students going 13, 12, 11, 10. Like they might be counting back by ones, and if we're expecting some tens, I might have some kids thinking about the fact that it's 10 and 3, or the meaning of the teen. If I sort of get rid of the 3 and 13 and 3 teen, then I'm left with just the 10 left over. But as a teacher, I would kind of establish that, and then I would Kim, am I on a number rack or am I on a number line? Let's do both. If I was on a number rack, I'm going to assume that if I'm doing this problem string, kids have done work on a number rack. So this is not their first shot at a number rack. So I'm going to say, how are you thinking about that? And when a kid says, well, I removed 3 from 13, then I'm going to show 13 by 10 on the top and 3 on the bottom. And I'm going to say, oh, you got rid of that 3. And I'll move the 3 on the bottom back over to the other side. And I'm just left with 10 beats. If I was on a number line, so it just depends on what my kids have had more experience with. If they hadn't had any experience with a number rack, I'll probably do on a number rack. If they are ready to think about things on a number line, then I would say, oh, so you're saying 13. And I would literally draw a number line, put a 13 on the right-hand side. I would jump back one jump of 3, and I would land on 10.
Yep.
And
Cool.
that's it. I
So,
wouldn't spend a lot of time here.
right.
I would also, if I'm doing this problem, probably not have a kid talk a lot about the fact that they just removed one at a time. I would just,
Yeah.
yeah. Okay, go ahead.
Yep. That's not going to be something you're modeling at this point.
No, not if I'm doing this
Cool.
string.
Yep. Okay. So the next problem is 13 minus 5. What would you expect to hear and model for 13 minus 5?
Yeah, so I might at this point say, I wonder if the first problem could help about maybe I don't know if we could, like almost don't finish my sentence a little bit. I wonder if I could help you. Maybe go ahead, use any strategy you want. And then I would let kids think and figure. I would watch to see who's counting by ones. I'd take note of that. And then I might say, hey, did anybody use 13 minus 3 to help you with 13 minus 5? And I'm looking for kids that, and then I'll call on a kid who says, now it's still a little bit of a, maybe they did, maybe they didn't, never quite sure with this age of kids. But I would try to pull out of a kid, somebody that said, well, if we know 13 minus 3 is 10, and I would redraw that number line, or I would re-put up the 10 beads and the 3 beads. And I would say, so we had 13. If I know 13 minus 3 is 10, move the 3 beads over, jump back the 3 on the number line. Then I could think about 13 minus 5 as 2 more than that. So if I'm on the number rack, I'd move 2 more beads on the top over. So I'm left with 8. I can clearly see those 5 beads and those 3 beads. Or I would remove 2, jump back a jump of 2 on the number line. And I would say, well, what is 2 back from 10? Oh, that's 8. And so that's how you guys are getting your 8. Does that make sense to everybody? That we could subtract the 3 to get to 10 and then just subtract what's left over, the extra 2.
Yeah,
cool.
Relating those two problems for sure.
Exactly.
What about 17 minus 7?
Again, I'm going to kind of watch. I'm not going to spend a lot of time here. Hopefully kids are using the meaning of the teen. I think I might stick with the number line from here on out as I describe it, but it'll be similar. I'll start on 17. I'll have some kids suggest that I've subtracted 7 to get to 10 and land on the 10. If I may, my board at this point, I've just, I'm actually drawing as I'm talking here, that number line that has the 13 is at a certain point, how do I say this? Left and right. It's and the 17 is about 4 to the right of that on the new number line. So when I've drawn that new number line, I didn't start the 17 in the same place that I had started the 13. I've scooched it over to the right about 4. And my jump of 7 landed in the same location as the 10s were in the top 2 number lines. So I've kept not vertically. Yeah, vertically. I've kept vertically aligned, horizontally aligned. I don't know how to say that. The tick marks for the 10 are in the same horizontal position, left to right. Go in those. Now I have 3 number lines, right? Because I have the number line for the 13 minus 3, the 13 minus 5, and the number line for the 17 minus 7. I've landed on the 10 in the same spot. So I've backed up 7 from that 17 that's further to the right. I know it's hard to describe that, but that's what it looks like. Okay.
Yep. Hey, I'm gonna derail this for just a second.
Yeah.
Because I've heard people say, in fact, people have asked, like, when kids are representing their thinking, do you require these specific directions about like how far and does it need to like perfectly line up? Or teachers will say, I struggle and I try. But I think maybe your point is that you're giving it a good go. It's not going to be perfectly proportional every single time, particularly if we're talking about kids, but the 17 should be the right of the 13, which should be, and the 10 should be to the left of the 13, and the 10s should line up together. But
I'm
you're
going to say that's
effort.
Absolutely. And that's only true for the teacher. I think the student doesn't need to be thinking about that at all. The student is just using relationships. Now, if the student wants to draw a number line to jump to be able to keep track of their thinking, absolutely. But in that case, I'm not judging that kid's proportional jumps or where they land at all, because they're using it to help them think. Now, I might look at what they did and help them find an error if they made a jump and they, like they subtracted 3 and they got to, I don't even know. And they were like, hey, what do you know what 14 minus 3 is? Oh yeah, that's 11, not 10, or whatever. That recording their thinking might be helpful, but no. So yes, good point. It's not about a perfect representation. It is about when the teacher is modeling student thinking, trying to get just as good as you can so that the relationships pop a little bit more for students. If the relationships are up there lined up, the potential for the relationships to to pop so that kids can develop that number line in their head is a little bit stronger.
Cool.
Yeah.
Okay. Back on track. Sorry. We did 13 minus 3. We did 13 minus 5. We just did 17 minus 7. So let's talk about 17 minus 8.
Cool. So I'm going to, again, ask students, did anybody think about using 17 minus 7 to help you get 17 minus 8? I'm going to look for a kid that does that. I'm going to redraw the number line for 17 minus 7 because the kid's going to say, yeah, because we do 17 minus 7 was 10. I redraw that. It now looks exactly like the one above it. And then they're going to say, but we needed to subtract one more. So I'll make a jump of 1 after that and land on 9. So 17 minus 8 is 9. And now I have 4 number lines on the board. And they've been sort of using the partner problem to help them with the second problem in the set.
Yeah. And I'm guessing, I'm betting that at some point you're standing back and you're like, that's interesting. And you're starting to maybe like ask or wonder or put some words towards like, what's going on here?
Yeah. Yeah. I might, knowing my kids, I might ask somebody, does anybody see how a similarity about how so-and-so, like Kim, used the 13 minus 3 to help him get 13 minus 5, and Aaron used 17 minus 7 to help him get 17 minus 8. Was there something similar about how they did that? And I might try to pull some words out of kids. I might also say, that's interesting that a lot of you got to the 10 first and then just kind of subtracted the extra. I might just mention that and then move on. Yeah.
Yeah. Because in all 4 number lines, they'd all be lined up together where there's a 10 on every single one of those number lines. I think that would really pop for your students. All right. Next problem, 15 minus 5.
Cool. I probably won't wait as long on this one. I'm watching kids. In fact, maybe I should say, if I saw a lot of kids counting by ones to get from the 13 minus 3 to 10 and the 17 minus 7 to 10, I might have also I might have put more emphasis on this generalization than the one you and I just talked about.
Right.
About getting to I might have said, so like 13 minus 3, 10, 17 minus 7, 10. So it's almost like we're thinking about the 10 and the teen, the extra stuff, and we're just like getting rid of it. So it's like there's this 10 showing up. That's what teens mean. I wonder if anybody can use that to help you think about 15 minus 5 rather than, like you can count back, but can you think about what 15 means to subtract 5? Like I might make that my emphasis. So again, know your content, know your kids. Yeah. And then I'll model starting at 15 and I'll jump back that 5 and I'll just note that my 10s are all lined up. So the 15 is in between the 13 and the 17. Kind of, I'll be honest. It's a little closer to the 13 than I wish it was. It's not right in the middle of the 13 and 17. It should be, but I'm writing in pen. So
I was going to say, too bad you don't have a pencil.
With kids, I'd be on a whiteboard, right? There you go. Okay. In fact, maybe that's worth mentioning. If you're on a whiteboard, you can easily erase, and we recommend that. If you are on a document camera, don't be Pam and do it in a pen. Do it on a small dry erase board. Put a dry erase board underneath or be Kim and use a pencil, because you do need to be able to erase. Though, don't you think, Kim, dry erase board is easier to erase than a pencil?
Honestly, it depends on the magnitude of the numbers, because sometimes if I'm dealing with large numbers, but also decimals, like that's, it gets a little bit more challenging. I want like a longer line to show a little bit more of the magnitude of the big numbers. So, and there's only so much space under document camera with a dry erase. Dry erase markers are fat. And so,
you can get thin ones. You can get through it thin. You would want to, so you're saying a pencil might be nice because you could draw finer stuff. Yeah. I also think it might depend on the reflection that you get off of the dry erase board under. Yeah. All right. Make that work. Okay. So we got 15 minus 5 is 10.
Okay. Last problem. 15 minus 8.
Cool. So I'm going to ask, hey, did anybody do that thing that Kim did and Aaron did with this project? Did anybody use the 15 minus 5? And I'm looking for glimmers of kids going, oh yeah. And then I might be like, oh, you were thinking about that? Even if you didn't finish, could you let's think that together. So if 15 minus 5 is 10, but we need to subtract 8. How much more? So-and-so, whoever I'm working with. Oh yeah. So we could just the extra 3. And what is 10 minus 3, everybody? We know that. I have, you need. If I have 3, what do you need? 7. Sure enough. So 15 minus 8 is 7. Yeah.
Cool. And so at the end of the string,
Mm-hmm.
depending on, is this your first go? Is this the third time you've done this kind of string? We talked just a minute about a little bit of a wrap up.
Yeah, absolutely. So it kind of depends on what I want to emphasize with my students at this point.
Mm-hmm.
So if a lot of them were counting by ones to do the 13 minus 3, the 17 minus 7, the 50 minus 5, I might make that be my point here.
Mm-hmm.
Y'all, like, we have this pattern that if I have a teen and I subtract off that bit of it that's the extra from the 10, what am I left? Wow, I'm always left with the 10. That seems important. Might that be something that I would pull out of kids, help me verbalize? But if that's not where most kids are struggling, then I might say, wow, this is really interesting that we could get to the 10 and then just subtract the extra stuff. I wonder if that could help us with problems in the future. So in some way, we kind of verbalize, put in words, help kids sharpen their thinking by putting it in words, the relationships that we're using in the string. And in this case, can we get to if we're subtracting, can we subtract to the 10 and then just subtract what's left over?
Yeah. Which is one of our major relationships that we want kids to own for subtraction.
Absolutely.
So it's a
Yep.
good experience. I think we have time for one more experience.
Okay, cool.
So will you talk through these problems as well?
I'm ready.
Okay. New piece of paper and clunky pen. 12 minus 6.
And my pen just leaked. You're loving it right now.
Sad.
Okay. So 12 minus 6, if we're doing this problem string, I'm not waiting very long on this. Doubles are things that kids kind of, like, we want to do things to help all kids build doubles, but they are a thing that kids tend to know. So I'll just usually, what is that? Everybody's going to say 6.
Mm-hmm.
At this point, I'm going to draw a number line starting at 12, and I'm going to a jump back of 6 and landing on 6.
Cool.
Okay.
13 minus 6.
To be clear, though, not because I said that, because I'm asking a kid to say that, and then I'm representing their thinking. Yeah, okay.
Yeah,
Sorry, what was the next one you said?
Okay, 13 minus 6.
So with 13 minus 6, I'm going to let them figure. Okay, that's the next problem. I'm going to figure. And I'm going to expect that there will be some kids counting back. I'm going to expect that there will be some kids kind of, like nodding their head a little bit, and I can kind of almost see them counting back by ones. But I'm going to ask, did anybody use the problem before? Like, if 12 minus 6 is 6, can that help you with one more, 13 minus 6? And I will probably even say that, one more, 13 minus 6. And then as kids describe their thinking, I'm going to draw a number line with a 13 just to the right of that 12, about one to the right. And I'm going to say, so if I jump back if this jump is the same distance, try to make that really the same distance, where would I land? If I subtract the same, but from one bigger, where would I land? And someone will say 7, and we'll land on that 7. So I should have two number lines that look exactly the same, but one is shifted to the right one, where in the first one it's 6 to 12, and on the 7 one it's 7 to 13, but the jumps are still all 6. Cool.
Which is why those attempt to be as proportional as possible is a huge goal, because that's that gap, or that minus 6 should look the same.
Yeah, absolutely. Right. And teachers, if you're trying to do that and you're like, like in the bit of it, it's not what you want. You can at that moment go, whoa, this doesn't look right. Y'all help me. What should this look like?
Yes.
And as the kids describe with the number line, like, like the 13 should be to the right of the 12. Well then guys, how big should the jump be? When I drew it way too big, because how should it relate to this jump of 6 up here? I mean, as they discuss that with you, they're it's not that they're really learning to model better, though they are, but they're really getting better at the relationships. They're owning, like, that should be the same length. Like, they're building spatial relationships. Yeah. Okay.
Yeah. I've seen you and I both do problem strings where we've sketched, an area model or a number line, and then we look at it and we've redrawn 2 or 3 times even. And the kids are involved in, like, why is she fussing with this? Like, what's wrong with this representation? So that she wants to redo it and make it better. And we're totally talking about, like, oh, does that feel okay? Like, does that seem?
Yeah. Ooh, how would you change that? And they're like, that doesn't look like a rectangle at all. Like, it should be more square, or that line isn't parallel. You're like, like the sides of a rectangle should be parallel. Well, that seems important. Like, all that stuff can come in. Yeah. Okay.
Okay, cool. Ready for the next problem?
Yep.
16 minus 8.
Cool. Another double. I'm not going to wait too long. I'm going to expect someone to say 16 minus 8. I'm going to draw a number line at 16 with a jump of 8 and landing on 8. Yep.
Cool. 16 minus 9.
Do you want to know that I just kind of I drew the jump and then realized that my jump was too short. So I scratched it out and made it a little bit longer. Anyway, okay. So now 16 minus 9, I'm going to ask, hey, is anybody, and I will actually suggest as I say 16 minus 9, I wonder if this problem could be helpful. I don't know, maybe go ahead and solve it any way you want. But then I'm going to ask, did anybody use the 16 minus 8? And now this time I'm going to start at the same 16.
Yeah.
And I'm going to say, what should the jump look like? Should it be shorter or longer than the jump of 8? Oh, it's a jump of 9. It should be a little bit longer. How much longer? 1 longer. Well, if it's 1 longer, then where are we going to land? Ooh, we're going to land on 7. So if I know 16 minus 8 is 8, then 16 minus 1 more than that should be 7. Cool. Again, pulling that out of kids, right? I'm trying to ask questions to get that for kids to say that.
Next problem, 14 minus 7.
Again, a double, not going to wait too long. Someone's going to say 7. I'm going to draw a number line with the 14, jump of 7 landing on 7.
And ready? 14 minus 5.
14 minus 5. And in this case, again, I might say, I wonder if anybody, this seems a little different. It's not just one off, but it's okay. Go ahead. Do whatever you want. Let them solve it. And then ask, did anybody use the 14 minus 7? And try to draw out someone who says, well, this time I didn't subtract as much. So should the jump be shorter, longer? It should be shorter. How much shorter? It should be 2 shorter. Well, what is 2 to the right of 7? Oh yeah, sure enough, that's 9. So if I've drawn that jump shorter, then, and I'm comparing it to the one above, I should be able to go, well, then if it's 2 this way, what is 2 that way of 7? Sure enough, that's 9. Oh, nice. So to finish up the string, wow, we really can use what we know. You guys, a lot of you are owning these doubles. Well, way to go. That's super that 12 minus 6, 16 minus 8, 17 or 14 minus 7. Those doubles. Wow, knowing those, you can use what you know to just adjust, either moving where you start or how big you jump. You can just adjust a little bit for when you know. Nicely done. Yeah, using doubles is super helpful. Cool.
Yeah, which is another one of our major strategies. And you've said a couple of times, I'm not going to stay long on this particular problem because my kids know their doubles. And so I can hear a teacher right now saying my kids don't know their doubles. And so one of our favorite routines is similar to I Have You Need. It's just a call and response. Is we do a lot with doubling and halving because we know that kids have some intuition with doubling, but we can strengthen that in moments of time where we double numbers together or we have numbers together. Later on as they get older. So
absolutely.
Briefly, tell us what that looks like.
Well, and let me also mention that we can also work on a number rack is going to just scream. The doubles just scream. So if I would have done that string on a number rack, as soon as I have 12 up there, depending on how I put the 12, if I put it as 6 and 6, like there's like, we're looking at the double of 12 being, or the double of 6 being 12. And so we want to work on a number rack can really help build doubles, but doubling and halving looks like literally, I've got a little bit of time. I got 90 seconds before we're standing in line, we're with the bell ring, whatever. And I might just say, hey guys, random number 15. What's double 15? And then I have to know my kids. So I have to know, do they have to think about that? But either way, once they tell it to me, then I ask them, how are you thinking about that? How did you find that? Okay, you need double 15. What double 14, double 16? So I might string it a little bit. I might do numbers. When I say string it, like do a series of problems that are kind of related. So if you know double 15, can that help you with double 16? Can it help you with double 17? So yeah, you literally just throw out a number, ask them to double it, tell them how they're thinking about it. And after kids have doubled a bunch over time, then a day I might go, hey, we've been finding lots of doubles. Let's have. Okay, guys, ready? What's half of 24? What's half of 75? Well, now I would do some work up before I do 75, but they might say there is no half of 75. It's odd. And I might go, if we have $75, can we split that? Oh, and then I want to sort of model the chunks they're doing. Anyway, so we could talk more about doubling and halving at some point, but that's a short routine that can help kids get facility with doubles.
Yeah. And once they own these strategies, right? Once kids have had experience with them, all these strategies that we've been mentioning over the last couple of episodes, it's okay in my mind to say, I see you counting and I know you can count fast. You've been doing that a while. And so your fingers fly, but we have relationships that we can use. And so I want you to use them.
Yeah. Hey, you're reminding me, we were going to mention that in last week's episode about the Trinity story, because literally that happened, right? You had a group of first grade kids and we were talking and you said, yeah, Pam, these kids own the strategies. and they're just quick. So whenever we clearly have developed strategies with them, but they count really quickly. And so when we say do this, or when we're working with strategies, they do them. But when we just give them a problem, or they're in the midst of another problem, they're dealing with counting by ones. And I was like, what are you going to do? And you're like, well, I'm just going to tell them to stop. And I was like, what?
Yes.
And so you did, right? Yeah, if I remember right, you pulled them together and you said, you guys, you own these strategies. When you see these problems, you're supposed to actually use the strategy. And the kids were like, oh, we are? And you're like, yeah. Yes. Yeah. And then you did it with them. You're like, okay, so when I see a problem like 13 minus 7, what's a strategy you could use? And the kids start counting. And you're like, no, we're not going to count on these anymore. I'm telling you, use these strategies. So those of you that are pushing back and you're saying to yourself, Pam, we don't want kids refiguring these problems all the time. There is a moment where you can say, I don't want you refiguring it with a less sophisticated, therefore take too much cognitive load strategy. I want you to actually dive into this strategy that might in the moment actually take a little bit more thinking, because I want to build these relationships. Then the facts become a natural outcome and so much more. Yeah. Yeah. Nicely done. All right, y'all. Let's help kids build their fact relationships and work with them enough to build so that they have the facts at their fingertips. Thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.